So it is saying that you are given an integer array nums and you are initially positioned at index first, right? So this is saying that you are initially positioned at index this one array, okay, first index, and each element in the array represents your maximum jump at that position, okay. So you have to determine if you can reach at the last position or not. Recursive backtracking solution, right? Start with a recursive backtracking solution. So first we will do recursive backtracking solution. Next, optimizing we will optimize that solution by using memorization table, and some people also say top down approach, right? Top down. And after that, when we remove the recursion, right, that is nothing but our bottom up dynamic programming. So apply final tricks to reduce the time. We will apply these tricks, and then we will reduce the time and memory complexity. So all solution represented here is below produced to the correct answer result, but they are different in runtime and memory requirement, okay. So let's start the first approach, that is approach 1, backtracking. So this is an inefficient solution where we try every single jump pattern that take us the first position to the last. We start from the first position and jump to every index that is reachable. So we will repeat the process until last index is reached. So when stuck, backtrack, okay. So how we can do that, right? So let's go to the code section and we'll do that. From here, the first step what we can do, we will take if condition, we'll do if condition if, and then we will check the position, right? We will find the position if that position contains data or not, right? So we have to in this case what we will do, first we will make a recursive function, okay. We will make a recursive function, and that function is what we will take return directly. We will make a function that will call a function can jump, right? Can jump, this is the function, and we can say that the name can jump from, right? And this is the position. We will pass the position, means one by one we will pass those. So we will start from 0, and then we will pass the array so that it will start from 0 to first index to the last position, right? So we have to create this function, right? This jump function we have to create. So how we will create this? We can write public, then boolean type, right? Because we have to return in true or false, right? Then we will pass can jump, and after that what we can do, we will pass this array and its position, correct? We have to pass. So I have taken 0 here, right, line number 3. So this is nothing but what? Position. So we'll take position and this array, and then we'll make this recursive function in which we will first check if position is what? Equal to nums dot length, right? And then minus 1. So if that is the case, what we will do, we will return true, correct? Means we have reached at that location, that position. We have reached to the last position, to the last index, right? So this is the case. Next, what we can do, we'll take an integer int, right? And then we'll say the furthest jump we'll find. Let's say this is the furthest jump that we have to calculate by what? We'll take math dot, there is a mean function, right? Math dot mean, in which we will pass position that we have find out already, plus we'll check nums how many position we have come, right? That have some value, right? That have some value, right? And then what we'll do, the length, nums dot length and minus 1, right? So we have the furthest jump we have. Okay, next we will make a loop, for loop, and then we will check the next position, int next position, and it is what? Our current position from the current position, and then we'll take one by one, right? We'll move to the next. So we'll do +1, and then next position, this next position is less than equal to what? This one that we have calculated from math.min, right? Whatever the minimum we have till that, and then this next position will do plus plus, correct? We will increment one by one, we will move next position one by one. So if I will talk about this function is going to return us what? True, right? When it will return, so if this function in which we will pass this position, next position, right, in place of 0, now we are doing recursively for all the index, same thing we are repeating. So if that is the case, right, if that will return true, then we will return true, and after that, after this loop, right, we can do return, right? We can do return. How? We'll return false if that is not the case, if we are not returning. So let's compile, working fine for me. Let's submit. Yeah, so this function, right, this function we have actually working fine, but have some complexities, right? So what we can see, that one quick optimization we can do for this code, right? We'll check the next position, right? We are checking the next position, right, from right to left, and theoretically worst case performance is the same, right? So but in practice, for silly example, the code might run faster. Intuitively, this means we always try to make biggest jump such that we can reach at the end of array as soon as possible, correct? So what we can do, a little change, like we are doing next equal to position +1, right? And then next will be less than equal to furthest jump, right? So what we can do, we can start from the furthest here. We can start the position plus, not the position +1, but we'll start from the furthest, this one, and then the next position is greater than position, right? Next position is greater than his current position. This is our current position, correct? And then we'll do minus minus here, like this. right? If we are able to find this, right, we will do recursively one by one. So let's see, we reached at the last? Yeah, we have reached the last, and so that we can submit our code, right? So for instance, the example here, if we are starting from what, 0 position, what we are doing, we are starting with the 0, right? So let me go to the board and then we will understand the complexity. Okay. Okay, so I was talking about the we have optimized our doing little changes, right? Initially what we have taken, we have taken for loop, right? The old loop we have taken int, right? And next position we have taken, right? Next position we have taken, and this next position I was starting from what, position and +1, right? And we are going till the position, we are going next position, we are going till what, less than equal to furthest jump, yeah, the last one. And then we are doing next position plus plus, correct? But now we can change this, and new what we will write, we will start this for loop from where, the int equal to next position, correct? And next position is what, the furthest position, right? Furthest jump, you can say that we are taking here, furthest jump, right? We will start from here only, and we will do next position should be greater than the position that we have started, right? And one by one we will decrease this, right? In so we are doing here, what we are doing here, we are doing there right to left, right? We are going from right to left. If this is the array, from we are starting from 0 index and it will go to the last index, right? But here we are starting from what, last index to the given position 0 index, right? Like this. So let's see an example, right? If we have an array, if we have an array like this, and this array is what, nums, right? That have value 1, 5, 2, 1, 0, 2, 0, right? And all have some index, right? 0, 1, we have 2, then 3, then 4, then 5, and then 6, right? So if we start from the index 0, this index, and as far as we reach at 1, as far we reach at 1 here, right? So what will happen, we have jumped what, 6, right? We will reach at 1, jump as far as possible and reach at 1, jump as far as possible, reach by 6, right? So by doing so, we determine 0 is a good index, right? If we have to move like that, okay? So to understand the illustration, right, what we have to do, we have to understand the worst case where the optimization has no effect, and that take the index 6, right? We can say index 6 cannot reach from any position, right? If we'll talk about this position index 6, so this is, here is 0, right? Obviously here is also 0. So how will, either we'll start from here, here, any position from there. If we'll move like this, so we cannot get what, we cannot reach here from any position, but all the combination we will try, right? And that is what, we can start from 0, then we can start from 4, then we can start from 5, then start we can 4, then from 0, like this we will do it is all the combinations, right? And that's why if we'll talk about the time complexity, right? So we are making what? Upper bound of jumping, right? And that is what? 2n. That is our upper bound. Ways of jumping from the first position, right? From first what position? 0 position to the last position, right? We are going 0 position to last position. If this is 0, give me a minute. If this is 0 and we are going to the last position, n position. So where n is the number of length of nums, right? Number of length of nums, the array. So for complete proof, we will see, we have to see a mathematical formula, right? How we have taken 2 to the power n, right? So there is 2 to the power n, 2 to the power n, and it's an upper bound, right? Ways of jumping from position, first position to last position. We are taking from first position to last position, right? And this is what? Index of num, that we start from index 0 to index last, right? So we get this recursively. Why? So let's understand t of x. There is a function t of x, and that will be the number of possible ways of jumping from position x to position n. If someone want to jump from here to here, right? This position to this position, okay? So if we talk about the t of n is 1, trivially, right? It means this is a function that will take I equal to what? X plus 1 until n, and that is nothing but what? T of I, correct? Because from position x, we can potentially jump to all the following position of I, right? That's why we can say that there are T of I ways. How many ways? T of I ways we have to continue and to reach after jumping to n. So we have to notice that this is a upper bound, right? And the T of x, we have this one, we have started with what? I equal to x plus 1 to n. And what is this function? T of I, right? So if we say that t x plus 1, right, and this above function, right, if we are starting from I equal to what? X plus 2, so this function will remain same till it will go to n. We are taking first position and this is the next position, right? So this ti will remain same, and we know that we have already calculated this is our now x plus 1, and this is, we know that x plus 1, correct? So 2 times we are moving, and that's why we can say that 2 into what? T x plus 1. And if we will reduce this, the t of x will become what? 2 to the power x, 2 to the power n, you can say n, minus x or minus 1, and will prove what we will prove? T of x, T of dynamic programming, okay? So first what we will do, we will take a memo, right? So what we can do, we will write a index, right? Index, we can say that, and this is what? This is a array, okay? So we will take as memo, correct? And this memo, oh sorry, we have taken wrong place, right? We should take here, right? This is our memo, okay? Because we have to memorize, right? We have to store the result, right? So what we can do, this is the function, right, we have, and the recursive function that we have taken last time, what we will taken, we used to return the value, right? We used to return the value. So that return is what we were doing, return can jump from what position, correct? This is the method we have taken, and we were passing 0 and then nums, correct? We were passing. Now actually we are doing memorization, right? So we already had memo, correct? So if this is our memo, that is what will take new index. Okay, we'll take new index and we will store nums dot length, right? We'll take nums dot length. We have initialized this index, correct? Now for all the value, for all the index, we will start from index I equal to what, 0. We'll start index I equal to 0 and we'll go to all the index, right? All till the last index we can say. So we will take length. So length like this, and then we'll take I plus plus. Okay, so now what we can do, we'll store memo at this point, right? So we will take memo at index, right? The index is what, I. Index is what, I, and then we'll take the index we have taken and we will take some value here, right? So for that we have to take a enum type value, right? So if I'll take enum and the index, right, we have to write, because we have defined our index, right, our memo, but memo is what type, index type, right? So I'm taking enum as a good, then bad, and then unknown. KNNOWN, unknown, right? So these three things we will have in the what, index. So we were talking about what, this value, right? Index dot this unknown value. If this is the unknown, we will set here. Okay, what we are doing here, we will take a memo, and memo is what, of this type, that can contains good, bad, and unknown, right? So when we are talking about this one, right, so we have memo, we have initialized nums dot length, right? This is the type of array we are taking, and then we will move I equal to 0 to the last length. Okay, and I plus plus. We will store all the store unknown initially in the memo of I, right? And then we will jump, we will do recursively and we'll check that, right? So how we'll do that? Here one more step we have to do, like memo at memo dot length, will take that memo dot length will take that the last position is, we are storing what, index dot good, right? We can say that we will store, and the recursive function that we have created, that is what we have to create similar to the previous one that we have taken, right? We'll take public boolean and this function, and this function will take what, this function will take what, this function will take two things, right? The position we have taken last time, position we have taken, and then we have taken int array, right? This is the array we have, and the array was a nums. So this array we have to move if memo at position not equal to index dot unknown will take, right? Index dot unknown will take, and here we will return what we will return. We will return memo at position we will take, and which is equal to what? Index dot good. If that is the case, then we will return what? We will return true. Okay, if not, then we will return false. Okay, so we can say we can put into this one for better understanding. That is not problem, we can take there also, but I am putting here only, so we will understand. If memo position at index not equal to unknown position, then we will see if memo position is at good index or bad index, right? Or there can be unknown index, right? See, we have already understand what is good index and bad index, right? You can see the first part if you have not gone through that, the first part. So please go through the first part and you will understand what is the good index and bad index. I was saying that good index is what? Where we can find the last, we can reach to the last position, right? And bad index is what? We cannot get the last position, right? And so that if we can reach, if a non position is not in the memo, then what we will do? We'll check if that is a good position, then that is what? True, otherwise it is false. Okay, so next what we have to do? We'll take a function that will take a that we have already taken the function jump, and we have did this, right? Now similarly we calculate furthest jump. We will take furthest jump, and that is what? We will do math dot mean, and that is what? Position, and we will position plus we have did last time nums, right? Nums at position, and then another value is nums dot length minus 1, correct? So which is minimum? That is our furthest jump, either position plus nums at position and the length minus 1. We have already done this one, right? This step. So similarly, as last step, we will do int I. Int I is nothing but, we can say next position, right? Next position, np, or we can write no problem, next position we can take. So next position is what? Position plus 1. Remember, position plus 1. We will start from position plus 1 for the next position, and next position, this next position is what? We can take, we will go to what? The furthermost, right? The furthest jump you can say. We have taken this, and this will come here, right? Till that we will move, and then this position we will increment what? 1 by 1, right? Like this. And so that we have to move till when? We will check first for each position, is next position, this function that is returning, right, can jump from the position or not, right? Because this is recursive function, right? So we have to do recursively all the time. So previously we have passed 0 position, now we will pass the next position, right? So this is the next position we have to pass, and we have to pass the nums for all the positions, right? If it will return, right, if it will return some value, that is what? For the good times, if we have reached at the position. If this is true, it means we have to pass memo at position, and we will store what? This is a good index. This is good index, right? And if we found this, then we have to return also it's true, right? So we will do true, we will return true. Otherwise, what we will do after completing this position, what memo at what position, memo at position equal to index dot good, index dot good, right? And then sorry, not index dot good, otherwise we will do bad, right? Means we have not found it, right? And then we will return false, return false, like this. Okay, so as you can see, what we have taken, we have taken a memo that the index will be either good, bad or unknown, and then we'll initialize the value, and for all the index we will initialize the memo of I is unknown, that is not, we don't know about uh, bad index or good index, right? After that we will set the last index what it is a good index, because we have to reach there, and then we will do recursively, we will check from index 0 to the last position, and this is our recursive function that will take care of two things. If that is in the position memo or contains already this unknown index, right, then we will return true or false, otherwise we'll store here. How we'll do that? We will find first furthest jump, right, from using this one math.min, and for all the position using position plus 1, we will check if the position, if the we can jump, if this is a good index, then we will store at memo at what position it is good index, otherwise we will return we will, in that case we will return true, otherwise we will return false, and we'll set the position is bad, right? So now we have understood this one. So let me run this code. Looks good. So we can talk about now complexity, right? Very good. Now we can talk about the complexity, and complexity is what? This is our DP problem, right? This is our DP problem, and time complexity, we talk about time complexity, so it will remain n square, right? O n square, you can say O n square, because for every element in the array, if we have I for index, we are looking at the nums of I element to the right, aiming to find good index, right? And num of I can be at most n, where n is the number of what arrays element, right? And so that will come to, we will go n square time, right? So we have to check all the time. So this is our O n square. But when we are talking about the space complexity, right, and that will what? O n, right? Because we are not taking we are taking what? O 2 into n, 2 times 1 we are taking. If we'll talk about, we are taking two things, 2 of n, right? But 2 of n is nothing but what? 2 of n. We have already talked about this one in the first part, right? Because n originates from recursion, and second n comes from what? The uses of memo table, right? But the 2n is what? N. So this is the time complexity we have. If you have any doubt, please ping me in the comment box. This is our top-down approach. If you want to understand dynamic programming with bottom up, or another approach that we can do with greedy approach, please ping me in the comment box. We can go through that. Okay, we'll make another part of this video, and then we'll continue. Thank you guys, thank you so much.